Okay, so let's start solving some numerical problems for this chapter. First question that we will solve is, an object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? So the question says that there is an object which travels 16 meters in first 4 seconds and then again 16 meters but in 2 seconds. So we need to find the average speed of the object. So the question number 1 is, so question says that from this point A the object is traveling, let's say, to point B 16 meters in 4 seconds, and then from point B to point C the object is traveling again 16 meters, but this time it takes 2 seconds. So we need to find the average speed. Now what is the formula for average speed? It is total distance upon total time. Average speed is basically total distance upon total time. So what is the total distance in this case? Object traveled from A to C, it is 16 meter and then 16 meters. 16 plus 16 upon total time is 4 plus 2. Okay, so this will give you 16 plus 16 is 32 upon 6. Okay, so you can solve this. 2 3s are 6, 2 16 times 32. So answer is 16 by 3 meters per second. So the average speed of the object will be 16 by 3 meters per second. Here we just need to apply the formula of average speed and you can calculate it very easily. Okay, so this completes the first question. Then the second one is, the odometer of a car reads 2000 km at the start of a trip and 2400 km at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in kilometers per hour and meters per second. Okay, so very interesting question. This says that there is a car and the odometer means the meter which is reading the distance traveled by the car. Okay, in a car you can see, in a two-wheeler you can see there is a meter in front. Okay, very small meter. It reads the speed. It reads the distance traveled by that particular vehicle. Okay, you will be able to see it looks something like this. Okay, and there are blocks in this and there are numbers written in this block 3 2 4 5, let's say like this. And as soon as you start traveling along using a vehicle, you will find that this number is getting changed. It starts from 0, it goes to 9, and then this number will change. It's again start from 00 to 99 and then this moves. Okay, so what is happening? This is the odometer which is reading the distance traveled by that particular vehicle. Okay, so in this question it says that there is a vehicle. In question number 2, there is a vehicle. The odometer of the car reads 2000 km at the start of the trip. So the meter shows at start of trip. At start of trip, the car has already traveled 2000 kilometers. Okay, so before starting my trip, I am not considering the past trips which the car had already traveled. I am considering my trip, and before the start of my trip, I can see the odometer of this car reads 2000 km. At the end of the trip, the same odometer reads 2400 kilometers. So how much distance did I travel in this trip? Initially the odometer was at 2000, after the trip the odometer is reading as 2400. So the distance traveled in this trip is 2400 minus 2000, that is 400 kilometers. This trip was 400 kilometer trip. How much time did the car take to travel this much? This distance is, the time taken by the car is, it is 8 hours or 5 hours, it is 8 hours. 8 hours. The car travelled for 8 hours. Our task is to calculate the average speed of the car. So what we can see, average speed, now average speed is what? It is total distance upon total time. This is the average speed. So how to calculate the average speed? Here we can see that total distance, if I talk about, the car has travelled total 400 kilometer distance. Now this total distance means the distance travelled in this particular trip. I am not saying the total distance travelled by the car till now, that would be 2400, but I am considering only my trip, and I am assuming that 8 hours, I need 8 hours to travel this particular 400 kilometer trip. So in this trip, how much distance, what is the average speed with which I have travelled? So here the total distance would be 400 kilometers, total time is 8 hours. So here I will write average speed would be 400 upon 8 kilometers per hour. So 400 upon 8, you can see this is 5 and this is 0. So this is 50 kilometers per hour is my average speed. Now the question says, find the average speed of the car in kilometer per hour as well as in meters per second. So it means I have to convert this speed into meters per second. So how can we convert this into meters per second? For that, let's understand a very simple concept. If I say 1 kilometer per hour. Now what is 1 kilometer per hour? It is the speed of any object. It says that the object is travelling 1 kilometer in 1 hour. Okay, in 1 hour it is travelling in 1 kilometer. Now if I convert this kilometer into meter, what will happen? This kilometer will become 1000 meters, okay, and this hours, if I want to convert hours into seconds, so 1 hour is equals to 60 minutes and 1 minute is equals to 60 seconds. So I will say it implies 1 hour will be equals to 60 into 60, that is 3600 seconds. So 1 hour means 3600 seconds. So I can say this particular speed in two ways. Either I will say that in 1 hour the object is travelling 1 kilometer, okay, or I can say that in 3600 seconds, okay, I can say either 3600 seconds the object is travelling 1000 meters. Now if you solve this you can see 2 zeros will get cancelled, 10 upon 36, so 2 5s are 10 and 2 18 times 36. This will give you 5 upon 18 meters per second. So it simply means that 1 kilometer per hour will be equivalent to 5 upon 18 meters per second. So I can write a simple conversion of kilometers per hour and meter per second. How can I write? I can say that if I want to convert from kilometer per hour to meter per second, I will multiply by 5 by 18. If I want to convert from meter per second to kilometer per hour, I will multiply by 18 by 5, that is just reverse. So in this case we have the average speed in kilometers per hour available with us, this 50 kilometers per hour. I want to go to meters per second, it means I want to go from this to this. So what should I do? I will multiply by 5 by 18. So average speed is equals to 50 kilometers per hour. It can be written as 50 into 5 by 18 meters per second, which is equivalent to, now this you can solve this to, let me use another color, this 18 9 2s are 18 and this is 25. So 25 into 5 is 2 125 upon 9 meters per second. So in meters per second, my average speed seems to be 125 by 9 meters per second, and in kilometer per hour it is 50 kilometers per hour. So from this question we learned a very important conversion of kilometer per hour to meters per second and meters per second to kilometer per hour. Just remember this simple table and it will help you to recognize it in the exam. Okay, so this completes question number 2. First note these two questions and then we will continue. Okay, let's solve the third question. It says Usha swims in a 90-meter long pool. Okay, she covers 180 meters in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and average velocity of Usha. So the question says that there is a person Usha, okay, she travels 180 meters in 1 minute. Okay, she has the capability to travel 180 meters in 1 minute. She is traveling with this particular data, 180 meters in 1 minute. There is a pool which is 90 meter long. So in this 90 meter long pool, what is happening? Usha is traveling from one end to the other end and moving back to the same end. Okay, so if I want to picturize this situation, so question number 3 we can see, let's say this is the point A and this is the point B. This is the length of the pool and this is 90 meters. So basically Usha travels from point A to point B and come back to the point A. Okay, she travels like this. She goes from point A to point B and then coming back from point B to point A along the same straight path, and we need to find the average speed of Usha, that with what speed basically the Usha is traveling along this path, okay, and also the average velocity of Usha. So how can we see? We can see that Usha travels 180 meters in 1 minute. So if she go from point A to point B and point B to point A again, you can clearly see that she covers 180 meters in 1 minute. So if I want to see that how much distance did she has to travel to go from point A to point B and come from point B to point A again. So total distance Usha travelled is, total distance that Usha travelled is from point A to B plus B to A. So point A to B is 90 and from point B to A is again 90, that is 180 meters. So Usha travels 180 meters total, and it is also given that she travels 180 meters in how much time? In 1 minute. So I will say, if I want to calculate the average speed will be total distance upon total time. So to calculate this, total distance is this and this, that is 180 meters upon total time she is taking. It is given that she takes 1 minute, that is 60 seconds. Okay, so if you solve this, 0 and 0 will get cancelled. This is 3, this come out to be 3 meters per second. So 3 meters per second is basically the average speed. Now if I want to calculate the average velocity, what is average velocity? Average velocity is displacement upon time. Average velocity is displacement upon time. Now what is the displacement of Usha? You can see Usha goes from A to B and then B to A back. So we can see she at the end of this situation she is again back to point A. So I will say that its displacement is, the displacement of Usha is 0 meters. Okay, it means she did not displace from her initial position. As we understood the definition of displacement, it is basically the shortest distance from the initial position. So she travels from A to B and again B to A. So it means she didn't have displaced from her original position. That's why the displacement is 0. Now if the displacement is 0, what will happen? 0 upon any time t. This will give you 0 meters per second. Time can be anything, it do not matter. Okay, the time is 1 minute only, but it do not matter because her displacement is 0. So we can see the average velocity comes out to be 0. So just see the difference between average speed and average velocity. Average speed is 3 meters per second while the average velocity comes out to be 0 meters per second. It means the velocity and the average velocity and average speed are totally two different quantities. Okay, they are different quantities. So this is the best example to explain the difference between the average speed and average velocity. You can practically see the situation here. You can even apply the situation. It's very simple. Go along a straight path and come back to the same position. You can calculate that average speed comes out to be a finite value, but the average velocity will become 0. Why the average velocity is 0? It's because of the displacement. Displacement is 0, so average velocity will be 0. Okay, so this completes question number 3. Now let's solve question number 4. Question number 4 says, starting from a stationary position, Rahul paddles his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies the brakes such that the velocity of the bicycle comes down to 4 meters per second in the next 5 seconds. Calculate the acceleration of bicycle in both the cases. So here we have two cases in this question, question number 5. Case 1 is from 0 meters per second. Now why I am writing 0 meters per second? It clearly says that Rahul started from stationary position, that is Rahul started from rest. Rest means no velocity, no speed, that is 0. Okay. So from 0 meters per second, Rahul attains a speed of, how much it is? It is 6 meters per second in 30 seconds. So how to calculate the acceleration? Acceleration is final velocity minus initial velocity upon time. Okay, acceleration means finally what the velocity it attained minus initial velocity, what's the initial velocity of the of Rahul upon how much time it required. So final velocity is 6 minus initial is 0 upon 30. When you solve this, 6 upon 30 is 1 upon 5. 1 upon 5 is 0.2 meters per second square. Because we are calculating acceleration, so the unit is, acceleration is 0.2 meters per second square. Okay. Now we are given with one more case, that is the velocity of the bicycle changes from 6 meters per second to 4 meters per second in the upcoming 5 seconds. So case 2, if we define from 6 meters per second to 4 meters per second in the next 5 seconds. In the next 5 seconds, the speed comes from 6 meters to 4 meters. So again we can calculate the acceleration. It will be equals to final velocity minus initial velocity upon time taken. So what is the final velocity? It is 4 minus what is the initial velocity? It is 6 upon time taken is 5. So this will give you minus 2 upon 5. Minus 2 upon 5. When you solve this, it will come out to be, acceleration is minus 0.4 meters per second square. The acceleration will come out to be minus 0.4 meters per second square. Okay. So this is the acceleration in both the cases. So this completes question number 4 and 5. Okay, so you note this, then we will continue. Okay, so let's now solve question number 5. So question number 5, it says, a train starting from rest attains a velocity of 72 kilometers per hour in 5 minutes. Assuming that the acceleration is uniform, find the acceleration and the distance traveled by the train for attaining this velocity. So question is very simple. It says that there is a train. It started from rest. Okay, the rest means from zero velocity, and it attains a velocity of 72 kilometers per hour in 5 seconds only. So here we need to calculate what basically the acceleration of this train. Okay, so question number 5. Previously I have written by mistake, the question number 4 was written as question number 5. So that question which we did here, it was question number 4. Now we are doing question number 5. So it says that train starts from rest. So the velocity of train is, initial velocity would be initial velocity is 0 meters per second, and finally the train achieves a velocity called final velocity. Final velocity is 72 kilometers per hour. Now we will convert this kilometer per hour into meters per second. How to convert it? We will multiply this 72 with 5 by 18. So here when you convert it, this will give you 4 into 5 is 20 meters per second. And how much time taken by the train is? Time is equals to 5 minutes. I will convert this into seconds. So 5 into 60, that is 300 seconds. So to calculate the acceleration would be final velocity minus initial velocity upon time. Okay, so if I write it in terms of equations of motion, this final velocity is v, initial velocity is u, this time is t, and acceleration is a. So our formula will become a is equals to v minus u upon t. Now v is, this is v 20 minus u is 0 upon t is 300. So when you solve this, it will be 20 by 300, this will get cancelled, and this is 15. So acceleration will come out to be 1 by 15 meters per second square. So this is the acceleration of this body. And the next thing we need to calculate is the distance travelled by the train for attaining this velocity. So how the train achieved this velocity, what is the distance travelled in that particular situation? For that, what we need to do? Now we need to calculate the distance. For this we will going to use equations of motion. Now we have 3 equations of motion. V is equals to u plus at, the second is s is equals to ut plus half at square, and third is v square minus u square is equals to 2as. So which equation we need to consider, we have to decide that. We need to calculate the distance. So what is the equation for distance? We have 2 equations which contain distance. Okay, that is s is equals to ut plus half at square, and second is v square minus u square is equals to 2as. Now which should I consider? I will consider that equation which has all the parameters. Okay, all the parameter means I will consider that equation, the values of parameters of which are given in my question. You can see if I consider this, s is equals to ut plus half at square. Do I have the value of u? Do I have the value of t? Or do I have the value of a and t square? Yes, I have the values available with me. So what I can do, I can consider this second equation s. Now what is u? U is 0 into time is t plus half into what is acceleration, it is 1 upon 15 into t square. So this will get cancelled, this 0 into 2 is 0, 0 into t is 0. So it will come out to be half into 1 upon 15 into t square. What is time? It is 300. So 300 into 300. I will write it twice. Now this will get cancelled. This is 10. So this comes out to be 3000 meters, or this comes out to be 3 kilometers. So this is the distance travelled by the train to attain this velocity. I can use this equation as well. It do not matter. You can go for this or either go for this. But consider that equation for which all the parameters, okay, the values of all the parameters are available with you. For example, in this question, if I do not have the value of time period, okay, the time the train achieves this speed or this velocity, if I do not have the value of time, I can consider this second equation, okay. Or for example, if I do not have this velocity of the final velocity, okay, if I do not have the value of final velocity, then I can go for this equation. It depends on you which equation you would like to use in this question. Okay, so this completes question number 5. Now let's move to question number 6. Question number 6 says, a car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate the acceleration and distance covered by the car in that time. So in this question, question number 6, what is happening? The car accelerates uniformly, means with constant acceleration. I am applying the equations of motion. The only reason for application of these equations is that the velocity or the motion that the object is performing is uniformly accelerated. The motion has to be uniform, either uniform or uniformly accelerated. It cannot be applied on non-uniform motion. This we have discussed when we discussed the equations of motion. I told you that equations of motion are applicable only when the acceleration is constant. When acceleration is varying, it's changing with time, then we cannot apply these equations of motion. So in this question, what is given? The car accelerates from 18 km per hour to 36 km per hour uniformly, means with a constant acceleration. So it increases from, so velocity increases from 18 km per hour to 36 km per hour. Okay. So what is 18? 18 represents the initial velocity, 36 represents the final velocity. So u is equals to 18 kilometers per hour. It can be converted to meters per second by multiplying it by 5 by 18 meters per second. So this will give you 5 meters per second. Now what is the final velocity v? It is 36 kilometers per hour. When you multiply this 36 by 5 by 18, this will give you this 36, 18 2s are 36, this is 5 2s are 10 meters per second. So the velocity of this car initially was 5 meters per second and finally it becomes 10 meters per second. In what time frame? The time frame is 5 seconds. So here I can write the time is 5 seconds only. In 5 seconds this situation happened. So to calculate the acceleration, acceleration will be equals to v minus u upon t. V is 10 minus u is 5 upon time period is again 5. So 5 minus 5 is, this is 5 upon 5, this is 1 meter per second square. So acceleration comes out to be 1 meters per second square. So what does this mean? It means that the speed of this car is increasing by 1 meters per second every 1 second. Okay, every 1 second the speed of the car is increasing by 1 meters per second. Okay, so this is the acceleration. Now the second thing we need to calculate is distance covered by the car in that time. So in this time period, how much distance the car has travelled. In what time period? From 18 km to 36 km per hour. To achieve the speed from, or to increase the speed from 18 to 36, how much distance the car has travelled. Now observe, in this question we have applied this formula to calculate the distance travelled. Now for this question let us apply this one. Okay, First I have to check that which of these formula I have to apply. First understand that, first decide that. And how can you decide? You can decide on the decide based on the values of parameters that you have. If I do not have time, okay, if I do not have time available with me in this question, I cannot apply this formula. But if I do not have final velocity, I cannot apply this formula. But you can see final velocity, time, initial velocity, acceleration, everything is available with me. So now it depends on me which formula I want to apply. So for this, let's apply this one. V square minus u square is equals to 2as. So here I will write v square minus u square is equals to 2as. Now what is v? V is 10. Square of 10 minus u is 5. So square of 5 is equals to 2. Acceleration a is 1 into s means distance. So here this 10 means 100, square of 10, then square of 5 is 25 upon 2. This is s. So the s will come out to be 75 upon 2, that is 37.5 meters. Okay. So the distance that car traveled to attain a speed of 36 from 18, it has to travel 37.5 meters. So if it travels 37.5 meters for 5 seconds, okay, its speed will increase from 18 to 36. These are the different way or different types of conclusions that we can draw. Okay. So this completes question number 6. Okay, so you can note this and then we will continue. Okay, let's solve question number 7. It says the brakes applied to a car produce an acceleration of 6 meters per second square in the opposite direction of motion. If the car takes 2 seconds to stop after the application of brakes, calculate the distance it travels during this time. Okay. So the question says that there is a car which is moving with the with some speed, okay, and the brakes are applied to stop the car, and the acceleration for this particular brakes are is 6 meters per second square in the opposite direction of motion. So what happens when acceleration is opposite to the direction of motion? It is known as the deceleration. Okay. So deceleration means to decrease the speed. So if the car takes 2 seconds to stop, so car takes 2 seconds to stop at some point. Okay. And we need to calculate the distance it travelled during this particular time. So what are the given things in this question? What are the given parameters that we have? We have the deceleration of car. I will write it as a is equals to minus, this is 6 meters per second square. Excuse me. So deceleration of the car is minus, or acceleration of the car is minus 6 meter per second square, because it is in opposite to the direction of motion. So this negative sign represents opposite to direction of motion. Okay. And then the time is also given. Time to stop t is 2 seconds. Now if finally the car is getting stopped, so what can be the final velocity of the car? I will say final velocity v will be equals to 0 meters per second. Now what was the initial velocity? How the car was travelling initially? The initially car is travelling with some velocity, but we do not know that velocity. Okay. Now question says calculate the distance travelled during this time. So as soon as the brakes are applied in the car, for how much distance or how far the car is getting stopped. So I need to calculate that distance. How to calculate the distance? We have two equations of motion which consider distance as one of the parameter, and those two equations are s is equals to ut plus half at square and v square minus u square is equals to 2as. In both of these equations, which equation should I use in this question? I will use that equation in which I have the value of all the parameters. Consider the first one, s is equals to ut plus half at square. Here, do I have the value of t? Yes. Do I have the value of a? Yes. Do I have the value of u? No. I do not have the value of initial velocity. So I cannot apply this. Consider the second one, v square, v, do I have the value of final velocity? Yes. Do I have the value of initial velocity? No. I do not have the value of initial velocity, so I cannot apply this one. So which should I apply? So it means I need to calculate the initial velocity first, that at the time of application of brake, the car was traveling with which velocity. Okay, I need to determine that at the time of application of brake, the car was traveling with what velocity. That velocity will be known as the initial velocity. Okay, so to calculate the initial velocity, we will apply v is equals to u plus at. Now v is given as 0, u is initial velocity u, acceleration is minus 6 into time is 2. So when you solve this, u will come out to be 12 meters per second. Okay, u comes out to be 12 meters per second. So 12 meters per second is initially the speed of the car was 12 meters per second. At the time of application of brake, the car was already traveling with the speed of 12 meters per second. Now its speed decreased from 12 meters per second and comes to 0 after 2 seconds. So this is how gradually the speed is decreased. Now to calculate the distance, what I can apply? I can apply any of the equation. Let's apply this one, v square minus u square. So equation is v square minus u square is equals to 2as. Now what is v? V is 0 square minus u is square of 12. This is 2 into acceleration is 6 into s. So s will come out to be 12 into 12 upon 12. Okay, this will be 0 and minus 12, v square minus u square. Acceleration is minus 6. I am sorry, I have written it as 6. It is minus 6. Okay, so acceleration will be, this negative sign will get cancelled. This is 6 into 12, 6 into 2 is 12. This is square of 12, 12 into 12. This 12 will get cancelled. It comes out to be 12 meters. So the distance after which the car is stopped is 12 meters. So for example, if I applied the brake here, the car will stop after 12 meters, okay, at the distance of 12 meter from the point of application of brakes. Okay, so this is how we can solve question number 7. This completes question number 7. Now let's solve the next question, question number 8. It says a bus starting from rest moves with a uniform acceleration of 0.1 meters per second square for 2 minutes. Find the speed acquired and the distance travelled. So in this question, what we can see, question number 8, bus starts from rest. Okay, the bus starts from rest, so it means the initial velocity u is 0 meters per second. It travels with a uniform acceleration of 0.1 meters per second. So acceleration is given as 0.1 meters per second square, and it travels for 2 minutes. So 2 minutes means 2 into 60, that is 120 seconds. So the bus traveled for 120 seconds with the acceleration of 0.1 meters per second. Our first task is to calculate the speed that it acquired after 120 seconds and also the distance it traveled during this particular speed change. Okay, so to calculate the speed, we need to apply first equation of motion, v is equals to u plus at. What is u? It is 0 plus a is 0.1 into time is 120. So this comes out to be 120 into 0.1 is 12. So this is 12 meters per second. 12 meters per second is the final velocity of the bus. So after 120 seconds, after traveling for 120 seconds, at this acceleration 0.1 meters per second square, the bus finally achieves a velocity of 12 meters per second. Now to calculate its distance travelled, we can apply S is equals to ut plus half at square. So u is 0 into time period is t plus half into acceleration is 0.1 and time is, let's write the time, it is 120 square. So this will be 1 upon 2 into 0.1 into 120 into 120. Okay, so you can solve this 0.1 and this point will get cancelled. So 12 12s are 144. So 1440 upon 2. So 1440 upon 2 is 720. So this comes out to be 720 meters. This is the distance travelled by the bus to attain this particular speed, okay, or this particular velocity. Okay, so this completes question number 8. Now let's move to question number 9. Okay, so question number 9 says a stone is thrown vertically upward in a vertically upward direction with a velocity of 5 meters per second. If the acceleration of the stone during its motion is 10 meters per second in the per second square in the downward direction, what will be the height it attained by the stone and how much time will it take to reach there? Okay, so very interesting question, the question number 9. It says let us assume that this is the ground and I throw a stone from the ground with a velocity of 5 meters per second in the upward direction. Okay, I am standing on the ground, I am holding a stone and I throw it vertically upward, exactly vertical. Okay, if I throw this stone exactly vertically upward, what is happening? This stone is moving in the upward direction. Okay, every time the stone is moving in the upward direction, but due to the gravity, due to the force applied by the earth, there is an acceleration of 10 meters per second square in the downward direction because earth is pulling the stone downwards. So due to the force applied by the earth, due to the force applied by the gravitation, there is a negative acceleration of 10 meters per second square. See, the motion of the stone is in upward direction while the acceleration is in downward direction. So here I will write, now you can see what will happen. Since the acceleration is in downward direction, the object, what will happen? The velocity of the stone will decrease. Okay, as soon as it rises upwards, its velocity will going to decrease. The reason, this acceleration is in opposite direction. So if I ask you what is the initial velocity of this stone, this stone starts from here and at some point of time in the, okay, and at some point of time in the sky, this stone will going to come at rest. At rest, it will going to stop at some point. In the sky it will going to stop at some point, then it will again fall down. Okay, so finally at some point in the sky, its velocity will become 0 because it will going to stop. If I throw a stone, for example, consider this chalk. If I throw the chalk like this and then again catch it, what will happen? If I throw it like this and again catch it, what will happen? It will go to some point, it will stop there, okay, and then come back. So if I throw it like this in upward direction, it means I am initially giving it some velocity and finally in the air it comes to the rest. So it means finally at this point of time the velocity of the stone will become 0. So I will write V, that is final velocity, will become 0 meters per second. And initially I am giving a speed of 5 meters per second. So I call this as initial velocity, that is 5 meters per second. And what is acceleration? Acceleration would be equals to minus 10 meters per second square because the object is travelling upwards while the force due to gravitation, it is due to that force there is an acceleration in downward direction of 10 meters per second square. So our task is to calculate how much height did this object attain or did this stone achieved. So you can consider here that the acceleration due to gravity, g we call it as acceleration due to gravity. You will learn this in force and laws of motion. At this point of time, just understand this. This is the acceleration created because of the gravitation. Now, due to this acceleration, the speed of the or the velocity of the stone will decrease as soon as it rises in the sky. Okay, at some point of time it will become 0 and then it will fall back. In whole process, this acceleration due to gravity will not going to change. It will remain 10 meters per second square only. Okay, it will not going to increase or it will not going to decrease. Neither its direction will going to change. Okay, its direction will also remain same, that is downwards direction. So it means here I can apply the equations of motion, because equations of motion are applicable only in those cases where the acceleration is constant, and here the acceleration is constant, so definitely I can apply the equation of motion. Now imagine the situation, it rises from this point and goes to this point, means I started applying brake from this point and gradually the speed decreases, and at this point the velocity becomes 0. So it means if I consider this situation, S is equals to or I can write V square minus U square is equals to 2AS. In this particular equation, I have the final velocity of the stone, that is 0 meters per second square, minus initial velocity is 5 square, and then 2 into acceleration is minus 10 into distance is S. Okay, so this will be 25 upon 20, it is equals to S. So S will come out to be 1.25 meters. Okay, now what is this S? S is the distance travelled by the stone before coming to rest, and in which direction the stone is travelling? It is travelling vertically upwards. So here I will say that this S represents the distance travelled by or the height attained by the stone. Okay, H. This H and this S are same. So H comes out to be 1.25 meters. 1.25 meters. Now, what other thing we have to calculate? How much time will it take to reach there? So to calculate time, we can use V is equals to U plus AT. V is 0, U is 5 minus 10 and then into T. So this will come out to be T is equals to 5 upon 10, that is 0.5 seconds. So it shows that the stone will come to rest after 0.5 seconds. Okay, in 0.5 seconds, the stone will achieve a height of 1.25 meters. Okay, and then it come to rest. Then it will start falling down. Okay, but our question ends here, that at what point of time the stone will come to rest in the atmosphere, in the sky, and how much height will it attain before coming to rest. Okay, so this is how we need to solve question number 9. This completes question number 9. Okay, so then you can note these questions and then we will continue.